Welcome back to our series on Introductory Statistics. I'm Mark Ledbetter. This is lecture video 19, part F. We're in chapter 5. We're going to finish up section 2, which is part 6 of chapter 5, but we're going to talk about the addition rule today. So we've learned how to use the tree diagram, how to calculate probability for compound events, both without replacement and with replacement. We figured out how to calculate probabilities for independent and dependent events. We've looked at the general multiplication rule. We've learned that. We've also learned the special case where the events are independent, that multiplication rule, or how this multiplication rule reduces to that. We've learned how to compute conditional probability in 3 different ways. And we've learned how to test whether or not A and B are independent. And just to refresh your memory, we could look at the probability of A and B is equal to the probability of A times the probability of B. Another way to do this is we could use conditional probability. Probability of A given B, is that, and there's a question here, is that equal to just the probability of A? Or likewise, we could use the probability of B given A is just equal to the probability of B. And we could calculate one, if we're given one and we can calculate the other, then we can see one side of the equation is what I mean, and the other side of the equation. We can see if those are equal. If they are equal, then A and B are independent. The same thing is true here. If these two sides of the equation are equal, then A and B have to be independent. We've also learned how to calculate a bunch of different probabilities using a table where we have all the information, including conditional probabilities where we can just reduce the our sample space to the case that was given, or the event that was given. Okay, so we don't have much left to learn, so let's see if we can finish off section 2. And section 3, we're just going to cover permutations and combinations in the next video. All right, so the addition rule. Here is the addition rule, definitely something you want to put on your formula sheet. So it says the probability of A or B is equal to the probability of A plus the probability of B, but we have to subtract off this intersection here. So let's talk about why we're subtracting the intersection from here. It seems like it's the wrong thing to do, like we're not including the intersection. We have two different, so we have a couple of different situations here. We're going to look at the case where A and B actually have an intersection, or they overlap, or they have elements in them that are the same. And we'll do a little example in just a minute. So if I take the probability of A, notice that inside of the probability of A, I have the probability of A and B. Then, if I take the probability of B, it also includes the probability of A and B. So, when I add the probability of A with the probability of B, I've included the probability of A and B twice. And to understand this, I have drawn out A or B. So in this case, we have our sample space S, we have event A, event B, and they have an overlap. So there is an intersection. So A or B is the shaded region in this picture. So it's A, it's the event, the probability of event A, the probability of event B, just the set A or B. The set A or B includes all of those values that are in A, along with all the values that are in B. And we only want to include these values once. So we don't want to include them twice. So when we take the probability of A or B, let me clean this up. When we take the probability of A or B and we add the probabilities, which makes sense in this case, unfortunately we have too much. This is too big because we've included the intersection here twice. It's because that intersection's inside of A. It's also inside of B. So since we've included it twice, we need to subtract one of those off. So we're going to subtract A and B, the probability of A and B. And then this will leave us exactly what we want, which is the shaded area. Everything in the shaded area only included one time. So this is when the events overlap or they are not disjoint or they are not mutually exclusive. So now let's look at mutually exclusive or disjoint events. These are mutually exclusive or disjoint events, A and B. So, or A with B. So another name for the or is a union. So we could say A union with B. That means we just put them together. We combine everything into one thing. So it may seem sensible when they overlap, and then some students think it's not sensible when they don't. So let me say that if I have a point over here that is only in A, I'm going to call this point x1. X1 is in A. It is also in the set or event A or B. It is inside that because it's in A, therefore it's in A or B. Similarly, if I put a point over here and call it x2, well, x2 is in B. It's also in A or B, that set. This is a set. It's a subset of S. A or B is a subset of S. A and B is also a subset of S. So in this case, if I have a point x3, then x3 is in A, also in B, also in A and B. X3 is also in A or B. So it's in A, it's in B, it's in A and B, the intersection. It's also in A or B because it's in the shaded region. Okay? So this is the union of A with B, or the union of two events. But what do we do when they don't overlap? Well, we're still taking the shaded region of both of them. It doesn't matter that they're not next to each other, that they don't overlap. The event A or B is the shaded region. So if I have a point that's in A, it's in A or B. If I have a point that's in B, it's in A or B. And none of the points can be in both A and B because they don't intersect. They are mutually exclusive or disjoint events. Okay? So here we're saying that the intersection of A and B is empty. There's nothing in that set because they don't overlap. You could say that it doesn't exist. We're going to say mathematically that it's an empty set. And remember, the symbol for that is this, I need to put the line a little more on an angle. And it's not a zero, it's a container. It's an object that holds something, and this object, this set, is empty. And we said that the probability of the probability of the empty set, by our definition of probability, is the number of items in the empty set divided by the number of items in the sample space S. But there are 0 items in the empty set, and that is divided by the number of items in S, which is 0. So the probability of the empty set is always 0. So if and I've explained that, if A and B are disjoint or mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, which is 0 because they don't intersect, so the intersection is an empty set. And so it's just equal to the probability of A plus the probability of B. So when we have disjoint or mutually exclusive events, we can just add up their probabilities to get the total. We don't have to worry about all the intersections, okay? Which is nice. And I've explained all that through here. Okay. So the addition rule for mutually exclusive or disjoint events is simply the sum of the events. Okay. Now, before we get to that, let's do a simple example. Let's say that I have A is equal to 1, 2, 3, 4, 5, and 6. It's the set of those 6 numbers. And let's say that B is the set 2, 4, I'm going to make this 4, 6, 8, and 10. Okay? Now, A and B is equal to the set of numbers that are in both. So I've got 4 and I've got 6. So this is 4 and 6. So I'm going to undo my underlining there. Okay. Keep it a little neater. Now, what is A or B? So in this case, I'm taking the union of both of these. I'm taking the elements that are in either one. I want all the elements, and I only want them once. So here I'm going to say 1, 2, 3, 4, 5, 6, 8, 10. Now here there are 6 items in A. There are 4 items in B. There are 2 items in A and B. There are 8 items in A or B. So I've got the first 6, 1 through 6, and then this is 7, this is 8. Now, let's assume that all numbers have the same probability of being selected. So the probability of A, and let's say that S, we've got to define S. S is equal to 1, 2, 3, up to 20. Yeah. So the probability of A is going to be 6 over 20. The probability of B is going to be 4 over 20. The probability of A and B is equal to 2 over 20. We can we can find the probability of A or B using the addition rule. That's going to be the probability of A plus the probability of B minus the probability of A and B. And that is going to be 6 over 20 plus 4 over 20 minus 2 over 20. And that's going to give us 8 over 20, which is exactly what we had here, 8 items. So you can see how this works, right? Okay. But what if we have, so that's having all of this information. Let's do another quick example where we're not given all of the information like this. We don't know the sample space. We don't know the individual items in any of the events. Somebody gives us a probability, some probabilities, and asks us to do some solutions. And so let's say that the probability of A is equal to 0.6. The probability of B is equal to 0.5. The probability of A or B is equal to 0.9. What is the probability of A and B? Now, usually when we see an and, we think the multiplication rule. However, if anywhere in your problem you see the or, if there is an or somewhere in the problem, think addition rule. So the addition rule says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now I want to solve for the probability of A and B. So this is a negative sign on this side, and there's an understood positive sign on the other side. So in order to get the probability of A or B to the other side, I'm going to need to subtract it from both sides. Oh, let me put it over here. And then, so that gives me, so that would give me nothing over here. And then I would have over here, I'd have the probability of A plus the probability of B minus the probability of A or B minus the probability of A and B. I want the probability of A and B on the other side. And then I have the probability of A and B is equal to the probability of A plus the probability of B minus the probability of A or B. So now we went from a negative A and B to a negative A or B, and the A and B is now positive. So what I like to do in my head when I see this formula, you can do all of that subtraction every time if you want. You can also, if you'd like, on your formula sheet, you can put down that the probability of A and B is equal to the probability of A plus the probability of B minus the probability of A or B. You can do that. Or what I do is I just look at this negative sign here and the fact that this is a plus, and I say, well, I can just switch these out because they're opposite signs. When I move the A or B over to the other side, it changes signs. And the same thing with the A and B, it's going to change signs. Since one is positive and one is negative, I can just flip them. I can just switch them out. Okay? So in our case, we want the probability of A and B, and so we plug in 0.6 plus 0.5. Now, if I stop right there, I have 1.1. I can't have a probability that's above 1. So I have to have something else. So this is a 0.9, okay, for A or B. And so I have 1.1 minus 0.9 equals 0.2. So this is the probability of A and B. Now let's look at our example. My thing froze up a little bit. Okay, that usually frees it up. So let's look back at our polygraph results. And I want to find the probability of T or P. Here's T. Here's P. So there's two different ways to doing this. I can use the addition rule, the probability of T plus the probability of P minus the probability of T and P. So from the table, this is going to be, the probability of T is going to be 47 over 98, and then the probability of P is 57 over 98. Again, this is 104 over 98, so that can't be the answer. It's greater than 1. We have to do some subtraction here. It doesn't always happen that they're bigger than 1, but it can happen. So minus the probability of T and P, that's 15 over 98. And that gives us 89 over 98. So what's the other way of doing this? Without using the multiplication rule, I want positive and I want negative, or truth, I'm sorry. So I'm going to do this a different way. So what I'm doing is I've got the positive, I got the truth, so what I'm going to do is I'm going to circle everything like that. And now I could just say it's equal to 15 plus 42 plus 32 over 98. Or if that's going too fast for you, I can do 15 over 98 plus 42 over 98 plus 32 over 98. I've only counted everyone in those two in the row and column once. So 42 and 32 is 74, 89 over 98. So you get the same answer. So with a table, again, things are really easy. If I want the probability of T or L, T is here, L is here. They don't overlap. There's no overlap here. So I'm going to have 47 over 98 plus 51 over 98. I'm going to get 98 over 98, which is 1. So in this case, it's just the probability of T plus the probability of L because they're disjoint. Now, anytime that you're taking the probability of OR for 2 columns or for 2 rows, they're always disjoint. So you're just adding the probability. If they're both in the row, if they're both rows, like positive and negative, there can't be any overlap. Because when you add up their totals, you get the total for the whole experiment, the whole test. So, same thing for truth and lie. The lie detector either said they were lying or the lie detector said they were not lying. Likewise, the person either told the truth or they told a lie. They didn't do both in this case. So, again, if you add things in a table, if you add the or find the or for two events that are both in the column or both in a row, they're going to be disjoint. Okay. Now, in this case, we only had 2 rows and 2 columns, so by adding the or, we ended up with 1. But what if we had 3 or 4 columns and 3 or 4 rows, and we added 2 rows? It wouldn't add up to 1 in that case. It would just add up to whatever that was. All right. So we've done the conditional probability already, so I'm not going to do that again. And we've already looked at the, so I've already done this. I did this earlier in the last video, so I'm not going to do it again. But just remember, the probability of A given B is not equal to the probability of B given A. You cannot change the order. All right, that's it for section 2. Sorry this video was a little longer, but I think it's better to do all of the addition rule together instead of breaking it up. Please remember to update your formula sheet. It's your sheet, so you can put what you need on there so that you can get the answers quickly. When you're doing homework or out-of-class exercises, when you're doing the in-class exercises, when you're doing the in-class worksheets, it's really nice to have a good formula sheet that you can go right to the formula you need, and you have enough notes on there so that you know how to use it correctly. If you have questions about the course content, by all means, please ask. I am happy to help you. Also, please take care of yourself, stay safe, because we want to see you here next time.